Okay, hello everyone at online and hello everyone here. I think we say hi to everyone. Welcome to the last session of the application of machine learning in cybersecurity. I'm going briefly through my presentation. Um, it's about graph theory. So again, as the talk divided in three sections. Overview of graph theory. What's graph theory in general? I'll just review and refresh people's memory. I'm sure most of you know of this information. I just refreshing your memory. Graph in cybersecurity, how people use graph in cybersecurity, and graph and machine learning. So what is a graph? Again, a graph is very old, simple mathematical concept. It's two set of vertices and nodes and set of edges that shows a relationship between the nodes. Graphs can have labels. Labels can be numbers, words, strings. It could be repeated. Sometimes labels, especially on the edge, can be used as weight. Labels don't have to be numerical, don't have to be unique, and graphs also can have attribution. I briefly mentioned in the video as well. Difference between label and attribution is difference. You can consider difference between your name and your personality. So attribution describes who you are, what sort of personality you have. Labels gives you your name, and the node is yourself, like something like that. Graphs are everywhere. Like you can practically analyze everything with graph, from cybersecurity, from internet networks, trust, like Twitter accounts. This image here on the right hand side is a graph of all the astronomical paper citation and their correlation, because me. So it's like all the words in astronomy and how the papers connected to each other. There are type of graphs that we use it. I'm not saying cybersecurity people use it more. I've heard more about them in our world. One of them is directed graph. Directed graph means nodes. The relation between nodes are directed. For example, if there's a social media account, Twitter account, so Billy follows Harry, so there is an edge directed to Harry that shows he follows him, but he doesn't follow Ruth, but Ruth follows Billy. So like it's always a relation, and it's not necessarily two-way relation. It could be some one-way relation. There is another graph bipartite graph or bigraphs. That means like two set of nodes. You can divide the graph to two set of complete disconnected nodes, and then they connect to each other. Like those different nodes are connecting to each other through different edges. Subgraphs are very useful. I put them. I'm not sure we call it a special type of graphs or not, but it's something we have to tag. Subgraph is just subset of nodes at a graph. Any subset you can choose, like for example here the ones colored in red, consider as subgraph. Another special graph is most famous one is trees. Like I'm sure everybody knows what trees are. Weighted graphs can consider as a special graph. Weighted means either nodes or edges have weight. Most of those edges that shows the weight between the connection between nodes. For each graph, we define something called degree. It means number of edges that's connected to each node. If it's a directed graph, we would have in degree and out degree. In some concepts, like if you want to see how important is a node or how busy is a node, number of degrees that easily shows you, like if you say okay 100, the degree of this node is 100, and like the rest of the average is like 10, you would say okay, this is an important node because like everybody connected to that. VAC path cycle, I'll just go through very fast. If you walk through graph, it's called VAC. Obviously, like if you start from one node and go edge by edge through the edges, go through the different nodes, it's called VAC. Path is a VAC that does not contains repeated edges, and the closed VAC is like when you come back to where you started. And there are different type of location, like description here. Why graphs are important? I think the visualization part, and also it can describe and show a complexity of the problem, topology of the data or problem. It's one of the main strength of the graph. Also, you can use it to describe a set of entities pairwise, entities pairwise very easily with it. It's hard to fake. Cal would attest to that. I'm not sure. When I put that, because especially Cal is adversarial, it's a challenge, right? Yeah, you can. Yeah, you can work on it to see if you can like fool that, but it's hard to fake. Like it's hard to. It shows up, like fraud shows up, like any malicious events, any anomaly shows up in graph. Like it's hard to fake the data. Graph in cybersecurity, threat intelligence team, they are a team that gather intelligence related to attacks or threats that coming. They get their sources from different locations. They are using graph massively. So for example, just quickly over there, I'm not going to whole graph, but if two attackers attack a system in through different methods, one of them comes through email, the other ones come through web, and deploy their code and everything with connecting the dots together and like mapping their view, you might ended up to say, okay, these two people probably from the same organization, right? And it matters. Like it matters on profiling the attackers, profiling the organization, knowing your enemy, and also if the case goes to the court or to the police, it helps them to like gather more information. Like it's help them to the case. Another thing is like creating attack mapping. So you can show the whole network of your computer system using a graph. It's super complicated graph probably in any organization bigger than like 1,000 people. I would say it's massively it would be massively complicated, like how computers connected to the network, how computers connect, how the servers connected and stuff. But then again, it shows if there is an anomaly connection, if there is a vulnerability, if there is an attack, you can find it through this type of mapping. Fraud detection, we are going to talk about it a little bit more. Today, I'm not going to talk about it. Spam detection. It's another, if there's a spam website, and like it targets your environment, you can use graph to find them. There are so many different papers. Like when I was searching on it, there are like lots of paper on web on spam detection using graph. And my favorite part of usage of the graph is an anti-money laundering. So this is something interesting that, can I walk or? Yeah. If you can use your mouse pad to point. I cannot. No. Okay, that's fine. Okay, that's okay, I don't know. No, you can just use the camera. Okay. So if person A send money to these 3 persons, and they start sending money to their friends or relatives. So person H sends money to G, G in 2 different times, 2 different values sends money to F, and J sends to I, and then this comes back to A, that comes back to A. So practically, if you look at this graph, person A send money out, and then after maybe windows of 2 days, 3 days, through the different complicated connection, and it could be way more complicated than that. It could go to offshore locations, it could go to different companies. It comes back to different person A, right? And that's how person A cleaned their data, their money. So dirty money came in, they just pass it around through different people, break in their networks, and these people send the clean money in. So that now the person has a trace of how they get the money. If you don't have a good graph capability, it's almost impossible to using databases, even relational databases, to find this behavior, especially if it's through different time. If it takes few days to deliver that, it's just it's almost impossible. But if you have a good and complete data set, you can see it very easily, how they did money laundering. It's almost, I've seen data sets like that before. It's very dreamy because you have to have an international type of data sets, right? But even sometimes you see this one goes out to different country, but very few days later, very similar amount of money comes back to this person from maybe another country to neighborhood. So you would see, okay, there were that money moved country by country, few countries that come back, but it came back and it's clean now, right? So
so even if you don't have a view to
the complete view, you might guess, you might guess that's how it's clean, that's probably what happened. Quickly, graph and machine learning. You can use graph in every stage of machine learning through data processes, data cleaning, for modeling, and for representing the results. Using graph to show your results, it's very effective way. People love to see graph, especially if interactive. They would love it. The business loves it. I never had. Did we? No, we never had a chance to show our results through graph yet. But if you have an interactive graph, that's why most of the vendors' products you see have an interactive graph somehow, because business love it, and it's easier to business to describe. It's not my fault. Sorry. For example, this is very easier to business to describe, to show it. Hey, this is how they do value entry, rather than going through complicated describing how machine learning works and stuff to the business. Right? One of the most important usage of graph is on feature extracting and graph embedding. There are different libraries: Node2Vec, Struct2Vec, DeepVac, deep features. These are the graph embedding models. You can extract features manually as well. You define the features, not manually. This feature, I never worked with it. It's during my search for this workshop I come up with it. It sounds very promising. It says we do everything DeepVac does, but we are very less memory intensive, and our results has our feature has names, and you can describe it to business. I'm going to try it. I didn't have a chance to try it, but it sounds really interesting. You can use graphs in machine learning to predict, to classify nodes, to classify edge, to predict edge, or use it for edge regressions. Anomaly detection is one of the main usage of graph, and anomaly detection in graph can be in any different area, like in tax evasion, in credit card fraud, in network, in web spamming, healthcare, in access management, in practically any place you have connection and anomaly, graph would help. Recommendation system is one of another system that you can use graphic machine learning. So recommendation system comes in place in business very handy when you want to say, hey, like this group of people have similar roles, so they have to have similar accesses. So when you want to onboard people, you can just create roles and automatically give them accesses and stuff, rather than they ask people to like apply for accesses one by one and we forget like 12 of them each time, or if the new access comes up, you can just bundle together. So that's why like recommendation system is useful in cybersecurity, and we can use graph to do that. There is graph neural network. I have zero knowledge of it. Amir is going to have another workshop, right? You're going to have another workshop of graph neural network. I'm going to participate in it for sure. Like encourage my team to participate as well. I just brought up the concept because something fancy it decides to use graph and neural network together, but as of now, just know that concept exists, and as advertised for the next workshop is going to, like we are going to have. What are we are going to learn here? Okay, now I can say for sure what we are going to learn. We are going to have to look at the fraud, some sort of fraud data, and use some graph capabilities. I'm going to show some graph capabilities on how to detect fraud or to interpret fraud. Like fraud is something like you cannot for sure say, oh, we solved it. This is how you solve fraud. Like we were talking today as well, like it's kind of hard to detect fraud. But yeah, we are going to use some extract some graph features that we can use it later in the machine learning, or just use it as it to predict frauds. And yeah, that's my overview of the presentation. Any question?